Again, consider if the surface is horizontal, rough surface with coefficient of friction force mu, with coefficient of friction force mu. Okay, the bodies were in this way, connected on the surface, connected on the surface. Now, and this mass 1, mass 2, and this is tension 1, tension 2. Now, the surface is rough in such a way that there is a friction force between the surface of mass 1 and the plane. Likewise, there is a friction force existing on mass 2 opposing its motion. Now, the friction force on mass 1, it is F1, and on mass 2, opposing the motion, it is F2. So the free body diagrams for these two masses, it is M1, for instance, there is a tension T1, but not T1 equals to T2 equals to T, because the string or the rope or the chain is the same in both mass 1 and mass 2. Okay, for mass 1, the force is acting, it is tension 1, this one, and friction force F1, its weight pointing vertically downward, M1 times G, and the normal reaction, call it R1. Okay, for mass 2, it is an external force F, the tension force T, its weight M2 times G pointing vertically downward, and the normal reaction R2. Now we are interested to obtain the expression for acceleration A, whose direction is towards the right. Okay, using Newton's second law of motion, Newton's second law of motion. Now for mass 1, the net force acting on mass 1 is given by mass 1 times acceleration according to Newton. Okay, the force is acting on mass 1 are tension 1 and F1. Okay, tension 1, which is the same as it simply can be written as a tension T. It is a tension and F1. Oh, sorry. Also in mass 2, there is a friction force F2. Sorry, friction force F2. So in this question becomes tension, then plus negative F1, because friction force F1 opposes the motion. This one equals to mass 1 times acceleration. This equation becomes tension T minus F1 equals to mass 1 times acceleration A. But friction force F1 is given by normal reaction normal reaction R1 times coefficient of friction force. It is coefficient of friction force times normal reaction R1, which is given by mu times m1 times g, because the normal reaction is balanced by the weight of the body. Now this question becomes tension minus mu, then m1 times g is given by m1 times a. Now call this the first equation. Also, for mass 2, the equilibrium force on mass 2 is given by mass 2 times the acceleration of the system. Mass 2 times acceleration of the system. Mass 2 times acceleration of the system. However, the forces acting on mass 2 are F, external force, friction force F2, and tension force. Also weight M2 times G, and the normal reaction R2. But the vertical seeking forces have no effect on horizontal motion. Okay. This equation becomes F then plus negative tension plus negative friction force F2, sorry, plus negative F2 then equals to mass 2 times A. We consider that the direction of our motion is towards the right hand side. Okay. It is F now. We write the equation as it is F minus tension minus friction force 2 equals to mass 2 times A. But F2 is given by mu times normal reaction R2, which is equal to mu times M2 times G. Now this equation becomes F minus tension minus mu M2 times G equals to M2 times A. This is the second equation. Okay, if we are interested to obtain the expression for acceleration A, now we use these two equations, equation 1 and 2, to obtain the interested equation, the interested expression. Okay. Make it the subject in equation 1, also in equation 2, and compare, or make it the subject, then substitute into equation 2. Now from equation 1, T minus mu M1 times G equals to M1 times A. Now T equals to M1 times A minus mu M1 times G. Sorry, not minus, it is a plus, because it was minus when it comes on the other side. Now it adds. Okay, substituting this into equation 2, we obtain F minus tension, which is, now as we substitute F minus tension T, which is M1 times A, then E plus mu M1 times G, now minus mu M2 times G equals to M2 times A. This becomes F minus M1 times A minus mu M1 times G minus mu M2 times G equals to M2 times A. Now, if we rearrange this equation, becomes F minus mu M1 times G minus mu M2 times G equals to m1 times a plus m2 times a. And when we commutate, this becomes m1 times a plus m2 times a equals to f minus mu m1 times g minus mu m2 times g. Okay, a associate a times m1 plus m2 equals to f minus, this is mu times g, then m1 plus m2. Now making a the subject, the equation becomes acceleration A equals to external force applied F minus coefficient of friction force times acceleration due to gravity, then m1 plus m2 divided by m1 plus m2. This is the expression for acceleration of the system, for the system of two connected bodies moving along a horizontal friction surface, where mu is a coefficient of friction force, can be dynamic or static friction.